Before we do the next example, let's review the derivative with respect to x of the natural log of the absolute value of x. Remember that we can't take the log of a negative, so sometimes when we write our natural log function, if we put absolute value bars, that allows us to have x be more values, right? Because you put a negative in there, the absolute value is positive, and you're taking the natural log of a positive, which is allowed to do. So whenever we take the derivative with respect to x, the natural log of x, we get 1 over x. That's the rule that we used back when we were doing derivatives. So what we have to know now is that when we have the integral of 1 over x dx, that's going to be the natural log of x plus c. Watch what happens if we try to use the power rule. If we try to write this x to the negative 1 dx, and we go by the power rule, which is to add 1 to the power and divide by the power, we would get x to the 0. You can never divide by 0. So we have to recognize that whenever we have the integral of 1 over x, that corresponds to the natural log function. So now let's do example 4. Evaluate the indefinite integral of negative 22.5t to the negative 3.5 minus 4t to the negative 1 dt. I'm going to go ahead and rewrite these. Negative 22.5t, negative 3.5 dt, minus integral 4t to the negative 1 dt. Now, anytime you have a constant, you can bring that constant outside. So let me go ahead and do this. You don't have to write it this way, but sometimes it makes it easier. So I'm going to bring my constant coefficients to the front. And so I'm going to reverse the power rule. Remember what that is. Now this negative 22.5 is going to be there, and it's going to be times. You add 1 to the power, and you divide by the power. We subtract when we're doing the derivative. We add 1 when we're doing integration. We'll come back and we will reduce and simplify in a minute. Now here, we have to recognize that this is the integral of 1 over t dt, and that means this function, or this part of the function, was a natural log function. And don't forget, once I take the derivative, there's got to be a plus c out here. Now I'm going to clean up this first one. I've got a negative 22.5. I've got a t to the negative 2.5 divided by negative 2.5. Well, negative 22.5 is going to be divided by negative 2.5, t to the negative 2.5. Then we have subtract the natural log of the absolute value of t plus c. So I've got to take my calculator out and divide negative 22.5 divided by negative 2.5. So I get 9t to the negative 2.5 minus 4 natural log of t plus c. So this is what my integral is. And the only thing else I can think of is, customarily we don't leave negative exponents, so that's going to be 9 over t to the 2.5 minus 4 natural log of t plus c. In your practice, if you see that MyMathLab will let you leave the negative exponent, I'll let you leave the negative exponent in your answers on a test as well.